morning, guys. My name is Hriday Sankal, and I'm here to explain the topic of file system interface in operating system. File system interface in operating system. Welcome to this presentation on the file system interface in our operating system. We'll explore how data is stored, organized, and accessed. Understanding file system is crucial for anyone working with computers, from developers to system administration. Our agenda includes an overview of file systems, users and system perspective, file attributes and operations, directory structures, access methods, mounting, protection, design challenge, and future direction. Let's dive into the topic. Overview of file system. File system defined as a file system is a logical method for storing and organizing files, making them easily accessible. It manages how data is structured on a storage device. Think of it as a librarian of your computer. Keep tracking of every piece of information and where it's located, ensuring that when you need a file, the system can find it quickly and efficiently. Key components of file systems: data, actual file content, directories are organizing structure, partitions are segmentations of storage. Common examples include NTFS like Windows, FT32 older systems, and EXT4 Linux, each with unique features and capability designed to optimize data storage and retrieval. User and system view of file systems. User logical view. Users interact with files directories in a way that seems logical and straightforward. They see files organized into folders and can open, edit, and save them easily. This user-friendly interface hides the complex process happening behind the scenes, allowing for nutrition and interaction without needed to understand the technical details. Subject's physical view. The operating system handles the physical storage and retrieval of files. It may logical file locations to physical storage location on the hard drives. The OS acts as a mediator, translator user request from the user to the hardware, can understand, ensuring efficiently design. File attributes and operators. File attributes are name, identifier of the file, type, format or extension, size, amount of storage used, permission, access rights, timestamps, creation and modification dates. And file operations. Create new file, open, access file, read, retrieve data, write, modify data, close, end access, delete, remove file. Each file has metadata, data about the data that is stored in the system, enabling the OS to manage and track the files efficiently. And directory structure, hierarchical structure, single level, tree structure. Now we will see the hierarchical structure. Files and folders are arranged in hierarchical tree-like structures. This is the most common and intuitive organized method. Single level, all files are in same directory, simple but inefficient for larger systems. Tree structure, a classic hierarchical with a root directory and subdirectories, allowing for extension organization. Navigation within the file system is done using path names, which can be absolute and relevant, and understand these structure is virtual for efficient file management. File access method. There are three: sequence access, direct access, indexed access. In sequence access, data is processed in order, one record after another, suitable for tasks like reading a log files. Direct access allow you to access any block of data directly, essential for the database and application need quick access to simplify data. Indexed access, users can uses an index to locate specific segments of a file, combining aspects of sequential and direct access for optimized performance. And system mounting concepts, process, and mounting points. These are three steps. Mounting concepts: integrating a file system into an operating system, making its files and directories accessible. And process: the OS checks the file system for consistency and then attached it to the directory structure. And mount points: specific directories where the file system is attached, defining its location within the system. Understanding mount points and permission is crucial for the managing the data and ensuring that file systems are correctly integrated into the OS, enabling the data. And now file system protection and security. Protection mechanism, access control lists, and data integrity. Protection mechanism: read, write, execute permission, control who can access and modifying files, ensuring data integrity. And access control list: detailed it's detailed list specifying access rights for user and groups, providing fine grade control. And data integrity: protecting data from corruption of unauthorized access is paramount, safeguarding confidential and available. And now challenges in file system design: data fragmentation, scalability, performance consideration are there. Data fragmentation: external and internal fragmentation can lead to slower access times and inefficient use of storage space. Unscalable: handling large directories and vast file size requires efficient algorithms and data structures. Performance consideration: buffering, caching, and journaling are used to optimize file system performance but must be carefully implemented. Accessing these challenges requires innovation solutions and performance and efficiency, ensuring that file system can make any device. Conclusion and summary. Uh, these are three steps: key components, efficient management, future actors. In summary, we explored the key components of the file system interface, the importance of efficient file system management, and future directions in this field. The future may bring AI assistant file management and seamless cloud integration. So this is the topic of file system interface. So thank you.